All right, folks, so now that we've talked a little bit about how the humerus interacts with the scapula and how the humerus interacts with the ulna, let's add on the last piece, which is how the humerus interacts with the radius. So if we look at our elbow joint, you'll notice that again, we have up here, we have the humerus. The head of the humerus sits in that glenoid cavity and articulates with the glenoid cavity of the scapula. And down at the bottom, we have the humerus interacting with the ulna and the radius to make the elbow joint. And this is the brachium or arm and the antebrachium or forearm. So you'll notice, first of all, that in anatomical position, standing straight up, palms forward, these two bones are parallel to each other. And on the inside, we have the ulna making that point of the elbow, which is always how I figure out which one it is, that point of the elbow. It's on the inside. And if you're ever not sure, you can also literally follow the point of your elbow up along the bone and be like, well, sorry, not up, down, and figure out which side of your arm it comes down to this side of my wrist, which is the medial or inside of my wrist. So the ulna is on the medial side, the inside, middle side of the forearm, and that leaves the radius to be on the lateral or outside of the forearm when we are in anatomical position. The ulna is what forms that point of the elbow. Remember, that's the acromion process. But we also need the radius to articulate with this bone. So let's look at that articulation. So on the humerus, we get ourselves oriented, and you can see that this big rounded area, this is the head of the humerus. And since that has to point in towards the shoulder, we know that this is the right shoulder. And if we come down here, you can also know that this is the front because here's our fossa for our elbow in the back. So we know on the medial side, pivoting on this trochlea will be the elbow, the ulna, and that should be on the medial side of the arm. Over here, towards the edge, will be where our radius attaches. So this is the trochlea right here, and this over here is going to be our attachment. It almost looks like it's part of the trochlea, but this side's the trochlea, and this is over here is our articular surface, our joint surface for the radius. So the trochlea fits right in there. Sorry, the trochlear notch fits around the trochlea, and we have over here a spot for the radius, and we actually call this is the head. We call this the little head because it's a little rounded surface that looks a little bit, not really very much, but a little bit like the head up here. So this is the head of the humerus. This is the little head of the humerus, and the fancy name, or the fancy way we say little head, is capitulum. This is the capitulum of the humerus. And capital refers to the head. So for example, if I decapitate you, I have chopped your head off. If you wear a baseball cap, it sits on your head. So capitulum is the little head. Head, capitulum, trochlea. So on the lateral side of this humerus is the capitulum, and the capitulum is going to articulate with the radius. So to get oriented to our radius, you'll notice that it looks similar in size and kind of general shape to the ulna, and they're both a lot more, it's okay. Good thing bones are pretty sturdy, because I'm about to juggle over here. It's very disrespectful. There we go. So you'll notice that these guys in the forearm are a lot more slender and narrow than the big sturdy humerus. And the ulna, as always, is very easy to identify because of this trochlear notch. The radius has some similarities to the ulna, but you'll notice it has sort of a point or a bulb right up here near the top. And then it has this kind of flat, rounded end like that. And actually the structure of this joint reminds me a lot of the sternal end of the clavicle. So for example, if I get the clavicle out, you'll notice that they both have that kind of flat, rounded end. And then the clavicle comes down to the acromial end where it's more flat. And this guy also comes down to this kind of broader, pointier shape. This is actually where your wrist is going to come in. But this flat, rounded end is actually the head of the radius. So this is the head of the humerus, the capitulum, the little head of the humerus, and then the head of the radius. And the head of the radius, this rounded surface, articulates with the capitulum, just like that. So you notice it's a pretty shallow little joint there, and it's got space right next to it for the ulna to sit in. And this point, this bulb, is actually pointing right in because that's going to help with that articulation with the ulna and the radius. So if I get my last bone in place here, ooh, I'm really jiggling. You can see that that point is fitting into that ulna just a little bit. So let me take these guys out. And you can actually see that these guys kind of fit together. Oops, not very well. These are probably not from the same arm. But you can kind of see how these guys fit. And so the humerus, we're almost done. Let's go ahead, before we look at the radius in more detail, let's finish the last couple features of the humerus. We have the capitulum, and then we go ahead and name these kind of pokey offy bits on either side that aren't part of this trochlea and capitulum. Trochlea, capitulum, and we have two pointy off bits. So condyle often refers to kind of a jutting out rounded surface of a bone. You could actually call this a condyle. You could call these guys condyles. But we're going to call these condyles as well. We're going to call them based on whether they're towards the inside of the arm or the outside of the arm. So if we get oriented here, here's the back of the arm with that fossa. So we know that this is the right arm bone. So on the inside, this is the medial epicondyle and the lateral epicondyle. And they are both muscle attachment sites, just like this greater and lesser tuberosity. Epi, by the way, means outside, so they're condyles that are on the very outside edges of this bone. They're on the outside of the trochlea and capitulum. Medial, lateral. All right, so let's look at the radius. And we have a head, and we also have a neck, and the neck is right here. And unlike the humerus, where you have this anatomical neck and this surgical neck, the radius, the neck's pretty much right where it looks like it is. It's right here, the neck of the radius. So now I want to go ahead and show you quickly a video that demonstrates how the radius and ulna interact when your arm twists and pronates and supinates. So let me go ahead and share screen. Give me 1 second to get this set up. All right, so this is not my video, but what we're going to look at here is how the bones of that elbow joint articulate. So we have up here the humerus. Towards the medial side, we have the ulna. Towards the lateral side, we have the radius. And let's watch when you twist your arm and turn that hand at the wrist, pronate and supinate. Let's watch how this joint moves. Let's naming the pieces here. Here we go. So as your hand turns to face down, that radius right here crosses over and twists. And the key thing here is that there's an articulation right here. So that again, there's an articulation point right here and an articulation point right here between the radius and the ulna. So we have two little joints. They're called radioulnar joints that allow that pronation and supination of the arm. And that clip was from a video called Bringing Anatomy to Life by 3d-yoga.com. So let's go ahead and keep going. And so when we look at these bones of the ulna and the radius, this point that sticks in is called the radial tuberosity. So again, tuberosity means a bump or a wart. And the radial tuberosity is actually just a little before that articulation point, or below that articulation point with the ulna, but it's actually going to be where the biceps brachii muscle attaches. So the biceps brachii is going to come down all the way along the humerus and then attach right here onto the radius and make that strong pulling point that's going to help with being able to flex that arm. So right above that, we have the, I'm going to actually show this on a figure because I think it's going to be a little easier to see, but we have the ulnar notch. So it is a notch in the radius, a shallow or groove in the radius that's going to allow the radius to articulate at that upper elbow end with the ulna. So if I show these guys, I should really just pull them up on screen. Let me just put them up on screen for you. This is figures from the OpenStax textbook. All right, so here we have, this is figure 8.6 from OpenStax. And what you can see is that this is an anterior view of this right forearm. Here's that faucet or a wrench part of the olecranon, or the olecranon process back here, and the ulna's trochlear notch. And here's that radial head. Here's that radial tuberosity that articulates with the biceps brachii, not articulates, is pulled on by the biceps brachii. And this kind of little groove right here, almost in the head of the radius, is the sorry, not the radial notch. This is the ulnar notch of the radia. And you'll notice the radius has an ulnar notch and the ulna has a radial notch. So the ulnar notch is on the radius, it's the notch for the ulna. The radial notch is on the ulna, it's the notch for the radius. Did I say that backwards, or did I can't even remember what I just said. But again, they're on opposite bones. All right, and that is one of the places where they rotate against each other to create that pronation supination at this end. Then there's all this nice intramembranous, membrane in between the bones, interosseous membrane. Thank you, intramembranous. Interosseous, by the way, means between the bones. It's not a word you need to know, but if you're wondering, this is the interosseous membrane, and that helps keep those bones joined nicely together so that they rotate against each other without coming apart. And here on the other end, this is our other little radioulnar joint. This is the proximal radial joint because it's closer to the origin of the limb. This is the distal radial joint down by the wrist because it's down distant from the body. And here we have the ulnar notch of the radius. So radial notch of the ulna up here, ulnar notch of the radius down here. Radial notch of the ulna, ulnar notch of the radius. All right, so if I put these bones together, let's see if I can get them to fit. Let's go ahead and come back here. All right, so here's our olecranon, or sorry, not our olecranon, our ulna with the olecranon. Here's our radius. And this kind of divot, let me show you on this guy. It's gonna be a little easier. Well, I really like I'm used to having my bigger skeleton models, but this place where the head, the capitulum, sits in the capitulum, that's where the head of the radius sits with the capitulum. And right here on the inside of the ulna is a little groove, a fossa, and that is the radial notch of the ulna. And this pushes in and sits into it. And then on the other end, we have the ulnar notch of the radius, and that's going to be the radius. This guy has a little notch on the inside of it for the ulna to articulate into. So here, get this guy oriented. When we come down, so we know this bump is going to be medial, so we can come down here, and this little groove right here is where the distal end of the ulna will sit. So that's the ulnar notch of the radius. And here's my ulna, so we can literally just sit that right in there, and that's how they'll articulate on that end. And then up here, we need this to fit like that. Here we go. You can see that the radius is going to sit, I think these bones are backwards. It's going to sit up in here. So actually, yeah, this is the problem I'm having here, is that this is actually for the other arm. These are opposite arm sides, but up here, along here, you can actually see this little divot right here. It's where the radius would articulate. All right, so ulnar notch is on the distal end of the radius. The radial notch is on the proximal end of the ulna. And I know that's very confusing. I think I said it backwards at some point during this lecture even. All right, so for the radius, we have the head, the neck, the radial tuberosity, the ulnar notch, and the last points are going to be down at the wrist end of this joint. So if we now move away from the elbow down to the wrist, we named this little notch in here, this radioulnar joint, with the ulnar notch of the radius, which is here on this radius and lets the ulna articulate. We also have a bump on either side of the wrist. So these little 2 points are the styloid processes. And in this case, the word styloid comes from the word stylus, which is a writing utensil, like you would write with a pen or a stylus. And so the styloid processes, they're the points at the outer side of my wrist. I can kind of see them here. So those outer bumpy points of my wrist, they're the pointy parts on the outer edges of the wrist that are on the ulna and the radius respectively. So they are the styloid process of the ulna and the styloid process of the radius. And you have to think, which one's medial, which one's lateral? Well, remember, the ulna is medial. So on the medial side of the ulna, right down here, we will have the styloid process of the ulna. And out here on the lateral side, we'll have the styloid process of the radius. So here we know that this is the radius, here's the head, here's that medial tuberosity, or specifically the radial tuberosity that's on the medial side. So down along here, this point is the styloid process of the radius, and it got that name because it looked like you could write with it like a pen, so pointy. Here, even more pronounced, we have our ulna, and you can see when we come down to the end, that is a very sharp point on the end of the ulna. It really looks like you could write with it. That's the styloid process of the ulna. All right, and I think that gets us through all the parts I wanted to cover. In the ulna, remember we have the olecranon process, which is the point of the elbow, the trochlear notch, the radial notch, the ulnar styloid process. Yes, okay. So the last bit, now that we're at the hand, is to get our wrist and attach our hand to our forearm, our antebrachium. So I do have a hand here, and the short bones of the wrist here, all these little bitty bones, are called the carpals. And you can think of it like carpal tunnel syndrome. So the carpal area is your wrist area, and these are the carpals, and they're a whole bunch of little short bones. And they don't really form bony joints, they form gliding joints. And so they all glide against each other. And then they articulate here and here with the ulna and the radius respectively to make a more complicated joint. So here we have the carpals. You do not need to know the name of each carpal. I just want you to know that there's 8 of them. So there's 8 carpals. So I wonder if I could even find all 8 on here. 1, 2, 3, 4, 5, 6, 7. Oh, and one of them you can only see from the side. 8. All right. Then we have, oh no, wait, this is the 8th one up here. It's just attached. All right. Then we have the bones of the hands. And so we have sort of along the fingers, we have a bone here, a bone here, bone here, and a little bitty bone at the tip of the finger. Set of bones, 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 bones. And these guys have names. These are the carpals, the wrists. So next we have the metacarpals, and meta literally means after. So these are the after carpals. And one thing a lot of people confuse is if I say, where are these bones in your hand? And you get your hand out, and I say, where are those bones in the hand? A lot of people are like, ah, they're right here. They're the beginning of the finger. But these bones are not where the finger begins. These are the bones of the palms. The metacarpals are in the palms of my hands. So they're running here inside my hand. These are the metacarpals. So this is the palm of the hand. And if I cover that up, you'll see now it looks a lot more like an actual hand because here's where the fingers start. These are your knuckles. And here's your 1, 2, 3 bones of the fingers. And you'll notice the thumb, this is the metacarpal of the thumb. The thumb actually is unique because instead of having 1, 2, 3 bones, it has 1, 2 bones. So the thumb is missing a bone. So once we get past the metacarpals, all of the finger and thumb bones are called phalanges or phalanx, which is the singular, phalanges. And this comes from the word a phalanx of soldiers, is like a bunch of soldiers all in a row. And so this is like phalanxes of soldiers. They look like lines of soldiers marching out, and that's why they gave them their name. And so we literally number these bones based on what finger they're on. The thumb is always the first, second, third, fourth, fifth. So you would say this is the first finger, second, third, fourth, fifth. And then you would say that this is the proximal phalanx because it's closest to the body. Proximal, 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 proximal. So this would be the third proximal phalanx of the left hand. And now we can identify exactly what bone has been damaged potentially, or that I'm using to give you guys the middle finger. So proximal, the outer one is the distal because it's most distant. Distal, 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 distal. And then these guys have a nice intermediate, and this guy doesn't. Intermediate, sometimes just say middle or medial or median. I think on your paper it actually says middle, so this is the middle pharynx. So proximal, middle, distal. 1, 2, 3, 4, 5. And now using number, distance from the body, and the fact that it's a phalanx, you can say exactly which bone of the finger you want to refer to. So a fun experiment is if you know that there are 8 bones on the wrist, 5 metacarpals, 5 proximal phalanges, 5 distal phalanges, and 4 middle phalanges, how many bones are in the hand? So see if you can figure that out. By which I mean, can you do math, I guess. And that is, gets us our whole arm. So we now walked through all the bones of the arm, starting with the whole pectoral girdle, the humerus, all the interesting joints that are happening here. And now that you have these arm bones in place, you can start going back and thinking about muscles and how they attach across these and how they create different movements at different types of joints. I'll go ahead and say this is a ball and socket joint. It has a lot of mobility. It can twist and rotate, abduct, adduct, circumduct. It can extend and flex. This is a hinge joint. It can only go flex and extend, but these guys between each other can pronate and supinate by rotating against each other. Here we have a gliding joint, but it can sort of flex and extend as it glides around. Your knuckles can do a lot. They can circumduct, flex, extend, abduct, adduct, but your bones within your fingers are, between your phalanxes, I should say, are only hinge joints again. They can only flex and extend. So think about the shape of the joints and the way they interact with each other and what types of movements are allowed at each part of the body. All right, and with that, I'm going to go ahead and sign off for today. I hope this was helpful for you, and good luck studying.